everyone. Today, as scientists, we are going to ask the questions that a scientist asks. We are going to make a hypothesis, and we're going to learn all about our variables, independent variables and dependent variables. Let me show you the materials you're going to need for this lab. Here are the materials that you will need for this lab. From your enrichment bag, you will need a pipette and a measuring spoon. You will need to provide a small container of table salt. Any salt you have at home is fine. You will need a few washed pennies, 2 plastic cups. Glass will be okay too. You will need some kind of a measuring device that will help you measure either in milliliters or in ounces. And you will need a large container of water. What we're going to do today is we are going to see how many drops of water can we fit on a penny. Seems like an odd question. How many drops do you think you can fit onto a penny? Well, we don't know yet. It's a very odd question. Is it 1 drop? Is it 10 drops? Is it 1,000 drops? You can make a guess in your mind, but you can't quite make a hypothesis yet. Give you some hints about water. We know that water is adhesive. That means that water likes to stick to other substances. But what's important here is that water is also cohesive. That means that water likes to stick to itself. Does that help you? Let's start off by doing the experiment and seeing how many drops we can fit onto this penny. For the first part of this lab, you will need 1 cup, 1 penny, your pipette, and water. Since we are not adding anything to the water, your measurements do not have to be accurate. You can fill the cup with water just so that you have easy access to get your pipette in there. Now you have 2 sides to the penny. We're going to use the head side. You're going to place your penny on a flat surface. And let's do a little refresher on how to use a pipette. This pipette right now is filled with air. Going to squeeze out the air, insert it into the water, and I'm going to fill up my pipette with water. Now we are measuring drops, not pipettes. So go ahead and practice how you can empty out 1 drop at a time. That's 2, 3, 4, 5. Now that you have become an expert on filling and emptying your pipette, we are going to fill our pipette once more. And now I'm going to add drops onto my penny, 1 drop at a time, and I'm going to count to see how many drops of water can fit onto my penny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, whoa, 18, 19, 20, 21, 22, 23, 24, 25, still going strong, nothing has spilled, 26, 27, 28, 29, 30, 31, 32, 33, oh, and we spilled. I was able to fit 32 drops of water onto my penny. It wasn't 33 because that 33rd drop made the water completely fall off the penny. Now it's your turn. I was able to get 32 drops of water to fit onto the head side of the penny. Now what I'm going to ask you to do is you're going to do this 3 different times. Each time, make sure you're using the same penny and wipe it clean before you start again. The reason we do it 3 times is to make sure we are being precise and accurate. Go ahead, try it, and make sure to record your results. Now your results may vary a little bit, but they should be close. Some of you might have gotten anywhere between 25 to 40 drops, and that's just fine. But should anybody get 2 drops or 200 drops? No, because we all used a penny. We all used regular room temperature water. We all used the same tool to dispense our drops. We didn't change anything from one person to another. The only thing that was different is the person dispensing the drops. Maybe there was a little bit of a counting error, or maybe pressing a little bit harder in between. But our numbers should be very, very similar. Now, what I want to ask you is the question. We know how many drops of water fit onto a penny. But what if we change something? What if I want to add some salt to my water? What if I make salt water? Will I be able to fit the same amount of salt water drops on my penny as I did with regular water? Now you're going to make a hypothesis here. This is where the hypothesis comes in. Your guess, your prediction. A hypothesis is always going to be an if-then statement. If I add salt to my water, then I will be able to hold, do you think, more drops of water or less drops of water? Do we know how salt affects water's properties? Remember, cohesive is the ability for them to stick together. That's why we were able to fit 32 drops. Will salt make it more cohesive or less cohesive? Go ahead, answer the hypothesis. For the second part of this lab, you will need your second plastic cup. You will need a penny, pipette, measuring spoon, salt, a stirring stick or another tool you can use to stir, water, and your penny. Now for this part, it is important that you measure the water accurately. I'm going to add 200 milliliters of water. That's about 7 ounces of water, and I'm going to pour that into my cup. Now I am going to measure 2 teaspoons of salt. That's 1 and 2, and add it to my water. Using a spoon or a popsicle stick, whatever you may have, you want to dissolve the salt in the water, creating salt water. Now that my salt has pretty much all dissolved, we're going to repeat this experiment exactly like we did before. I'm going to use the head side of a penny and my pipette, but this time I am adding salt water, and I'm going to count to see how many drops of water fit onto the penny. Going to squeeze out all the air of my pipette, insert it into the cup, and again, we are going to count to see how many drops fit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Well, how many drops fit this time? Only 23. The 24th drop didn't make it on. Now go ahead and try this experiment with your salt water and see how many drops of water you can fit on your penny. Now that we've done both parts of this experiment, let's go over our results. When I had regular water, I saw that I was able to fit 32 drops of water. When I switched to salt water, I was only able to fit 23 drops of water. I was able to fit less drops of water when I had salt water. Now we can go back to our hypothesis and see if we are correct or not, but it doesn't matter. Your hypothesis does not have to be right. The hypothesis was, if I add salt to my water, then I will be able to add more drops of water or less drops of water. Then the conclusion is, if I add salt to my water, I will be able to add less drops of water. Now, salt does break up how cohesive water is. It actually makes it less cohesive. But what I want to talk about right now are the variables in this lab. We changed one thing. That one thing that we changed is called the independent variable. In this lab, the independent variable was water versus salt water. We didn't change anything else. I kept my penny the same, used the same head of the penny, used the same way to dispense my drops. And it was the same person dispensing the drops each time. Now we said the independent variable was the one variable that we changed. We had control over. We were able to add the salt to the water and test how many drops of salt water fit onto the penny. There's another variable here. The dependent variable is the result which depends on the independent variable. I know it's confusing, a lot of words, and they sound very similar. Independent variable, dependent variable. Independent variable is what we control. We added salt to our cup of water. The dependent variable is what we were measuring. And what we measured were the drops of water that fit onto the penny. Now, the amount of drops that fit on the penny, did I control that? Was I able to decide how many drops of water fit onto my penny? No. What decides how many drops of water fit on this penny? The independent variable. Because the dependent variable depends on the independent variable. It depends whether we had regular water or salt water. So many terms, but we are going to use these terms a lot for the next few labs. Let's go over and do a quick recap. The question was, will we be able to fit more drops of water or less drops of water if we turn our regular water into salt water? The hypothesis, always an if-then statement. If I add salt to my water, then I will be able to hold more drops or less drops of water. Now we changed one thing here. In any good experiment, you can only change one variable. We changed the type of water. We changed regular water to salt water. And we were measuring drops. The amount of drops we call the dependent variable. Those are our results, what we measure. Independent variable was the one variable we manipulated, the one thing we had control over. And here in this case, it was the salt. Now, can you think of other things that we could change? What are some other variables that we have power to change? Think about it, list them on your sheet, and we'll go over it in a minute. Well, we used regular water and salt water. What if we changed the salt water into another type of water? What if we used soapy water? What if we used lemonade? What if we used another drink altogether? That's another variable that we could change. That would be another independent variable. We'd still be measuring the amount of drops that were on the penny, and that would be our dependent variable. What else could we change? Well, could we change the penny to a nickel, a dime, or a quarter and do the same experiment? We could, right? We could change from a penny to different coins and see, does that affect our experiment? And in that case, we would have to only have one independent variable. We would keep the water the same. We wouldn't be using salt water anymore. And we would test to see how many drops of water fit on a penny versus a nickel. And that would be the one variable that we would change. What else could we change? We used the head side of the penny. What if we use the tail side? That could be another variable that we change. So many different variables that we could change here. But you have to always remember, in any good experiment, you only change one independent variable at a time.